In the previous sets of videos, we've learnt about the IUPAC nomenclature and then basically how to name various compounds. In this video, we are going to be solving a few in-text questions. First, structure and IUPAC names of the compounds are given. Explain why the names in the parentheses are incorrect. So here we have a compound called as 2,5,6-trimethyl-octane. We need to figure out why 3,4,7-trimethyl-octane is incorrect. First of all, the trimethyl-octane part is the same in both cases, and 1, 2, 3, 4, 5, 6, 7 and 8. This compound consists of 8 carbon atoms, which means it's an octane. So let's number this. The reason there are two different names which are possible is because you have second and the fifth and the sixth position, whereas so this is going to be at the third, a fourth and the seventh position. So now we need to decide why 3,4,7-trimethyl-octane is wrong. This is because of the first point of difference rule. So we had discussed that. So according to that, between 2 and 3, 2 is lesser, and so this is correct, whereas this numbering is wrong. So 2,5,6-trimethyl-octane is the right one, and due to the first point of difference rule, 3,4,7-trimethyl-octane is wrong. Next, 3-ethyl-5-methyl-heptane. I think this is to do with having equivalent substituents at equivalent positions. This was again discussed. So between in the first case and this is going to be the second case. So the ethyl group can either be in position 3 or it can be in position 5 based on the numbering, whereas the methyl group can be in position 5 when ethyl is 3 and position 3 when ethyl is 5. So according to the alphabetical order, ethyl gets the lower position compared to methyl, and that is why this numbering is correct, whereas the second one is wrong. So in the second question, that's 12.8, we need to give the IUPAC name for the following compounds. So the first one, we have an alcohol group over here. So this becomes the principal functional group, and it's going to be denoted by ON. Now let's count the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7. That's one possible chain, and the second one would be 1, 2, 3, 4, 5, 6, 7, 8. And so the 8 carbon chain 8, or rather the number of carbon atoms equals to 8 in the parent chain, so it's an octane. So this is a suffix. We know the word root because of the number of carbon atoms. Now we need to decide on the prefix. So the prefix would be the methyl group. With that, we're done with half of the name. Next, we need to decide on the numbering of the carbon chain. So let's start from left to right. 1, 2, 3, 4, 5, 6, 7, 8. And we also have to do from right to left. One more thing, if you find it easy and if you're sure of your answer, you need not number it from right to left and left to right. It's just that I find it easy for people to understand if they can, see what the numbers should be. So it's your choice. So 1, 2, 3, 4, 5, 6, 7 and 8. So the alcohol group should have the least number. So that is a principal functional group, and its locant should be less, however less that is possible. So between 6 and 3, 3 is obviously less. So the alcohol is present at position number 3 and the methyl group is present at position number 6. With this, we can find out, or rather, we can write the name of the compound. And the name of the compound would be, first the prefix 6-methyl then our word root, octan. Third position, we have an alcohol, octan 3, all. So this is the name of the compound. Now you can directly write it, or I mean, it's up to you, but for you to understand this better, I'm just writing stuff here. Okay, now this, sorry. Okay, so this group and this group, both of these are the same. Okay, they're ketones and they're no other functional groups. So the name of the compound would end, or the suffix of this particular compound is going to be dione. Okay, now let's count the number of carbon atoms. 1, 2, 3, 4 and 5. Since it has 5 carbon, 1, 2, 3, 4, 5 and 6. Since it has 6 carbon atoms, it's a hexane. And the word root is going to be hexane. Now, we need to number the carbon chain in such a way that both the ketones get the less position. So, or the locant value is less. So, 1, 2, 3, 4, 5 and 6. So, it is at the third and the fifth position, or it is at 1, 2, 3, 4, 5 and 6. So it can be at the second and the fourth position. Now by this point you would have realized, because of the first rule of difference, so first point of difference rule, we'll be comparing numbers 3 and 2, and 2 and 4, I mean 2 is less than 3, so 2 and 4 is the right numbering. Okay, so we are numbering it from right to left. That is the right one. So the name of the compound would be, here we don't have a prefix because there are no other substituents or side chains. So hexane because you have, hexane because you have an ketone. It's a ketone and it's ONE, so the E gets removed. Hexane 2,4 dione. So 6-membered ring, the second and the fourth position, there are ketone groups in each. Let's go on to the next one. Here we have two functional groups. One is an acid and the other is the ketone. Now between ketone and acid, based on what we have learnt up to, with respect to the decision on the principal functional group, we know COOH gets more priority than ketone. This means that the COOH will be denoted as a suffix, whereas the ketone will be denoted as a prefix. So the prefix for ketone is oxo. Okay, and the acid is going to be oic acid. So this is the suffix, this is the prefix. Are there any other side chains or something? No. Now let's count the number of carbon atoms. 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms, so hexane. Now we need to number this chain. It's obvious that since our COOH is there on the right side, the numbering is going to go from right to left, and COOH gets number 1, 2, 3, 4, 5 and 6. I'm not going to go from left to right because COH is here and it has number 1. So oxo is at position 5 and COOH, that is the acid, is position 1. So the name of the compound is 5-oxo, that's the ketone's position, noic acid. Since acid is at the position 1, you need not number it separately. The last compound. Here in this compound we have both a double bond as well as a triple bond, and we've already discussed that when there are both double and triple bonds, double bond gets gets more priority, and the triple bond is considered to be the part of the parent chain. So here 1, 2, 3, 4, 5, 6. So there is one triple bond, it is denoted by "-ine", and the two double bonds are denoted by "-diene". And the double bonds are at first and the third position when we write numbering, when we number it from the right to left. When we do it from left to right, there are positions 1 and 5. So again, sorry, 3 and 5. So of course 3 and 5 is going to be higher than 1 and 3, because of which the diene's position is 1 and 3, and this is the right form of numbering, and the triple bond is at position 6. And since it's a 6-membered carbon chain, it's a hex 1, 2 diene, and we will remove the E because there is another substituent, another suffix over here, and 6-ine. Here the E is present because there's nothing after this, so here no E. Then with this we're done with the in-text questions. In the next video we'll be continuing with the in-text questions of the nomenclature.